Well, hey, everybody, it's time for our next lab. We're moving on to lab 5B. So instead of studying momentum uh, before and after a collision, we're going to study changes in momentum during collisions. And so it sounds like a minor difference, but it is a pretty important distinction. So let's start out with a quick lesson just in case you need a refresher course or in case they haven't gotten to this in the lecture portion of the class. We start out with the fact that just like last week, momentum is equal to mass times velocity. But we need to take a look at what happens when a change in momentum occurs. So if we're going to change momentum, we're changing a velocity. We'll get to that in just a second. But if we're going to change something's momentum, it requires a force to do so, a force over a certain amount of time. The fact that force equals change in momentum divided by change in time is actually known as the impulse momentum theorem. And it's also valid in multiple dimensions as well, like many things in physics. We could consider a change in the x direction momentum that results in an x direction force. A change in the y direction momentum would result in a change in the y direction force. So, in summary, you can see here that in any collision, which is what we're studying this week, as well as last week, an object's momentum is changed simply because the velocity has changed. I mean, this could also happen if the mass changes, but we're not dealing with that scenario. Essentially, if there's a velocity change, this is what's known as acceleration, right? This law is essentially, or this theorem is essentially equivalent to F equals ma. So whether we're dealing with sort of the modern understanding of the second law, F equals ma, or whether we call it change in momentum over time, the units are the same. They result in, it gives us a way to find force. And of course, that would be the derived unit for a Newton. So let's take a second while I switch gears here a little bit. We'll talk a little bit more about the experiment and what you're going to be dealing with this week. Okay, so this week, as you probably read about, we're going to be dealing with collisions involving first this kickball. If you were here, we would have set up our high-speed camera again, and we would have taped a target to this ball. Quite simply, we would have done this while the camera was rolling. Doesn't seem like much, but it's actually a collision, and it's a collision that results in a change in momentum. A change in momentum comes from a change in velocity. A change in velocity comes from changes in the rate of position over time, all of which can be pretty easily measured by tracker. So the data analysis that you're going to take a look at here in a second simply involves using tracker to keep track of this object's position. We can then calculate its x and y velocity, how much that changes, and therefore derive its momentum and any changes in momentum that results in an exerted force, in this case, the force that's been exerted by the table. In the second part of today's experiment, we're going to study a collision between your fist and a board. Yes, I'm talking about karate chops. One thing we would do if you were here is we would take a simple pine board like this and put some chains around it and keep stacking more and more mass on it to determine its static load test. Essentially, what is the static load or the greatest amount of force that board can withstand before it snaps and breaks. Typically, we can get in the 50 to 100 kilogram range, believe it or not, before this happens. But how can I do something like this very simply? Well, the reason is actually the impulse momentum theorem. The collision between my fist and the board took place in a very small amount of time. So if you take a look back at that equation, F equals change in momentum over change in time, as long as I make the change in time a very small number, the force can be a very large number. I'm not that strong. I can't just snap a board in half in my hands. But if I use the impulse momentum theorem to my advantage, keep that delta t really small, I can snap a board in half. And as a result, I can create hundreds of pounds of force with that really small delta t value. So now that you've seen what we're actually doing, the two collisions we're studying, the collision between the kickball and between my fist and that board, it's time to move over into the tracker software. Again, you're not here, you can't use it, but I uploaded some previous videos into tracker software for this exact purpose. As you can see here, I have a kickball drop playing in the tracker software. I've used Auto Tracker, the same software we used in week 2. And I also, you can, just to remember here, this is that calibration stick. It has to be properly set for this. What I'll provide you with is a template in Excel that already has the data exported. Again, if you follow the directions carefully in the lab manual, it walks you through this, so I'm not going to say too much more about this. I just want to highlight the fact that we do give you a number of good screenshots here in case you need some help or are answering some questions in the lab report. I'd also like to highlight this alternate force method here. We previously dropped that kickball on a force plate. Force plate is simply a piece of equipment that measures the amount of force that's pushing down on it and displays that on a screen. It takes pretty high-speed results, and so this is included in a tab in the Excel spreadsheet that I'll be sending to you. And so we can see here that as that ball hits, even though the ball doesn't weigh anywhere near this amount of force, it takes that much amount of force to change its momentum and therefore its velocity so quickly. Well, good luck. Please reach out to me with any questions. I'll be in touch about an online meeting sometime during our regularly scheduled class time. Always feel free to reach out to me via email, or we can do the Google Hangouts thing as well if you'd rather have a live chat or conversation. Best of luck to you. Stay safe, and we'll see you soon.